Hello everyone, it's Yamin from the tech team. In this video, we're going to learn how to extend the functionalities of a universal profile using LSP17 contract extension standard. So before going into the LSP17, let's start with the universal profile. A universal profile is an LSP0ERC725 account, and when we go to the spec, we see that it's a non-biased smart contract account, which means it have basic functionalities like executing, setting data, validating signature, ownership management, being notified about different actions and reacting on it, and a unified way to interact with the contract. So here we can see most of the essential functionality of a universal profile. And once it's deployed, we will just have these native functions. So imagine someone wants to add a specific function to the universal profile after it has been deployed. Should he create a new universal profile with this functionality? Obviously not, because your universal profile will hold your reputation, which you cannot migrate to a new one, because whenever you deploy a new account, the address will change. And you'll need to migrate your data and your tokens, which is not an easy thing to do whenever you want to add a new functionality to the universal profile. So what's the solution? The solution is LSP17 contract extension, which is a standard that the universal profile adopts that will allow for the contract to receive function calls of function that does not exist natively in the contract and forward it to an extension where it actually exists, passing the relevant information. In this way, even after deployment, smart contracts will have the ability to support new functionalities. So here, for the universal profile, we can see that we can add extension. And why is this useful and needed is because, for example, this profile will be deployed at a certain stage in time, but even after deployment, the process of standardization in the ecosystem will continue. So other standards will get adopted in the future, and the profile might need to support them. Similar to what's happening now with EIP 4337, where in order to be compatible with the standard, you'll need to have a function called validateUserOp, which you can see on the screen that we can add as an extension. And also some tokens require a specific function that return a bytes 4 value in order to make a safe transfer successful, like ERC721 and 1155, which anyone can decide to support by adding the relevant extension. So LSP17 not just ensure the ability to extend the profile with new function and interface IDs, but also emphasize on the point that a universal profile is a non-biased account, where only essential features are within the account and everything else can be added as an extension. So we're going to see a demo on how to add the extension to the universal profile and what you can do with them. So I created a hard hat project, and you could easily do that by doing npm I hardhat, and then you will install hardhat. And after this, you would need to initiate the project. So you do npx hardhat init. I created a hardhat project using TypeScript, but feel free to do it with JavaScript if you're more comfortable with it. So you'll get a hardhat project, and then you would have some templates in contract scripts. But this is the main template that we're going to use, and then we'll expand from this. And at the end of the video, you can go to this GitHub repo where you'll find all of the final code. So the package that I'm using are prettier, hardhat.env. So you just install .env to put the environment variables. Also, we're using the LSP smart contract package. So you'd also need to download it in this way, because we need to extract some constant, and we're going to use some contracts. So you'd put that into the env. So I created a sample file for the env. So we'll need the private key of the browser extension controller. There will be other tutorials that show how to extract that from the browser extension, and we would need the universal profile address. And obviously you would put that into the .env. I will not show you this because it contains my private key. So we have this main setup. I'm going to explain it. So we import ethers, we load the environment variables, we import the universal profile API from the LSP smart contract package, and then we connect our code to the Loxo testnet. We initiate the signer, which is the browser extension controller, and we create an instance of the universal profile using the address that we imported from the environment variable and the universal profile API, so we can interact with the function of the universal profile and the provider, which is where the universal profile actually exists, which is on the testnet. So I'm gonna run this script so you can see I can see the address of my browser extension controller and the universal profile, and then we're gonna start. So we're gonna start by calling a function that does not exist on the universal profile, and I'm gonna take this main setup and I'm gonna put it here. And because we're gonna call a function that does not exist, we're gonna create a new API. So let's say the function that does not exist is called buy me a coffee. So this is the function, and now we're gonna update the universal profile with the new API, which is this one, and we're gonna try to call it, and we're gonna see what's gonna happen. So we connect to the signer, so the browser extension controller will be executing this transaction, and then we're gonna try to call the function, and let's see what happened. So it's gonna revert, so execution reverted, unknown custom error, and if we take the signature and we put it into the bytes for dictionary, so we just do this and then we extract all of this thing, take the first 4 bytes, we're gonna see that this custom error is for no extension found for function selector. So this means that this function, which is buy me a coffee, does not exist natively on the UP, and also there is no extension for it. So what we're gonna do is that we're gonna go create a new contract. We call this contract coffee maker, and we're gonna put this function here. And then at the end, we're gonna add this contract as an extension for the universal profile. So here we inherited the LSP17 extension contract because it provides some utility functions that we're gonna see. So we have extendable message data, extendable message.sender, and extendable message.value. So I explained this before, but what's happening is that a person or an address is calling the universal profile with this function, and then the universal profile is calling the contract that will be added as an extension. So that means the message.sender of the universal profile is the actual person calling, but the message.sender of the extension will be the universal profile. So if we're gonna do some validation based on like who called the extension, we cannot do message.sender because in this case it will be the universal profile address. So because we're appending data to the extension, we can access that with the extendable message sender. So that means this is the person who actually called the universal profile with the function selector, and we can also get access to the extendable message.value. So we can see it here, extendable message.value, which is how much this person have sent while calling this function. And the universal profile will obviously communicate this information to the extension. And if you go to the specification of the LSP0, you will see how you can do some configuration in order to make the value forwarded to the actual extension. But in our case, we'll just see how it's communicated. So we're gonna proceed with adding the function that we agreed on its name, which is buy me a coffee. So we're gonna create a public function, and we're not gonna do anything complex. We're just gonna create a public variable called coffee revenue, and this coffee revenue will be increased each time send us value. So we're gonna say that the coffee revenue will increase each time someone sends value to the universal profile. So in case it's deployed on the Luxo network, it will be licks, how much licks you're sending. So we're gonna deploy this. It's super simple. So obviously if we run the script again, it will still fail because we just coded the solidity part and we didn't deploy it or add it as an extension yet. So what we're gonna do is that we're gonna do npx hard hat compile, then we're gonna add the function that does not exist. So we're gonna take the main setup, put it here, and now we would need several stuff. So first we need to deploy the coffee maker. So we're gonna take the factory from the type chain, and then we're gonna say that this is the coffee maker. We're gonna attach the signer who's gonna deploy it. And here we can just log the address of the coffee extension .target. So there's the difference between Ether's v6 and v5. So if you're using v5, it will be here .address instead of .target, but I'm using the latest version. So we can deploy it, but at the same time, let's add it as an extension. So what we're gonna do is that if we go here, we can probably take the function signature of the function, which is this one, buy me a coffee. But we're not gonna take it from here. What we're gonna do is through the code, we're gonna say that buy me coffee selector is equal to ethers. Then we're gonna use the ID method. We're gonna say we're gonna copy the function name so we get that correctly. And then this will result in a 32-byte hash. So we're just gonna take the first 10 characters, which mean it's OX, and then 4 bytes, which is the function selector. After this, we're gonna construct the data key of adding the extension. So we're gonna use the ERC725 data key, which are provided by the package. So you can import that from the package. And here you can use some utility libraries like ERC725JS to construct the data and fetch them from the contract, but I will try to do it without them to also emphasize that if it's a simple thing, you can do it without the library. But if you have many fetching and constructing, it is recommended to use ERC725JS or the utilities of the LSP smart contract. So I'm gonna construct the data key by saying constructed data key equal. So first we take the ERC75Y data key, which is the LSP17, and we take the prefix. So the prefix will be 12 bytes, which are defined in the standard. And now we need to take this 4-byte selector and pad it. So we're gonna use ethers.0 pad bytes, this one. And then we're gonna take the selector and we're gonna pad this by 20 bytes because it's 12 and we wanna make it as 32-byte data key. And then at the end, we're just gonna remove the 0x from the front. So this is the constructed data key. And now what we're gonna do is that we're gonna set this data key with the address of the extension. So what we're saying is that whenever the universal profile is called with this function selector, call the extension which we deployed here. So this is what we're gonna do. We're gonna set data on the universal profile using the signer. And here it's important to note that the signer, which is the browser extension, should have all the permission needed. Here the permission needed are add extension, which if you want to modify, you'll need edit extension. But make sure that your universal profile browser extension controller have the add extension permission. There's other tutorials that show how to detect this and how to add it in case you don't have it. So we're gonna call set data, and then this is the constructed data key, and the data value would be the coffee maker address, which we can access by doing this. And then we would need to wait till the is mined. So now we're adding function that does not exist. Let's see if we made some mistake. Hopefully we didn't. Okay, we can see that it's deployed, and we can take the address, so we can use it later, and we can put it here. So this is the address of the coffee maker extension. So everything went through, and now if we try to call the function that does not exist a second time, hopefully it will go through. npx hard hat, but we need to make sure of the requirement of the function. If you had some requirements here, you need to make sure these are fulfilled. So here we can modify it to say require that the extendable message.value is more than 5. And this way you're requiring that anyone who wants to buy you a coffee, that he send you more than 5 way, or like you can put it whatever value you want. So we're gonna call the function again. So we're gonna try to call the function after adding it as an extension. And we're gonna see that this time it didn't revert actually. So this time we're calling it, and what we're doing is that we're saying the extendable message.value is incremented with how much value we sent. So here we didn't send any value, so I'm gonna try to say I'm gonna send so let's see the default. Okay, let's take the main setup and check the extension. So this is the address of the extension. So here we're saying the ABI, we don't need to use the universal profile ABI. We're gonna say the ABI is function coffee revenue, then it returns a UN256. Let's make sure it's correct. Yep. And then we're gonna instantiate the extension with this address and with this ABI and with this provider. So we don't need to use these ones. And now what we're gonna do is that we're just gonna call the extension with this signer, and which function we're gonna call is the coffee revenue dot static call. So here we're gonna do a static call, and so we're gonna put the result, and then we're gonna log the result. Hopefully it will go through. So now what we're doing is that we're checking the extension if there is some changes, and it's checking the extension. So here it showed 0 because actually when we called the extension here, we didn't forward any value. And let's see now if we forward some value, if it will work or not. So I'm gonna send 7 way. Here we didn't put any restriction, so we can send as much as we want. So I'm gonna send 7 way, and I'm gonna do calling a function that does not exist. And we can see it takes some time, so it can get mined on the blockchain. Okay, let's check now if the revenue went up. Let's do check extension. Hopefully we can see, yeah, you can see that it went from 0 to 7, which is actually the number that we sent. So this can show you that you can even control in the extension the value that can be sent to your universal profile while calling a function that does not exist. So this gives you a big amount of flexibility. So the last thing we're gonna do is that we're gonna try to also extend the universal profile with other interface ID. So the whole point of extending with function is to add new functionalities to the universal profile. But what usually websites do is that they check an interface ID for the universal profile if it's supported. so they can start preparing to call a function. So if you go to the universal profile now, you can see that it supports ERC75X and ERC725Y. And what websites do is before doing any transaction, they check if it supports this interface ID, and if it doesn't support it, it just don't do the call. So now we're gonna create a new contract, and let's call this contract supports interface. And then just name this. We don't need actually now the extension, just for simplicity. I would do function support interface. It will take bytes for. And then public, and it will return a boolean whether this interface ID is supported or not. So for the simplicity, we're just gonna hard code it and say if it support ABC, AB, AA, BB, C, C, D, and we're gonna compile. It went through. Now what we're gonna do is take the main setup and put it in calling supports interface. What we're gonna do is just simply call the UP, because the supports interface function exists on the UP, but we just want to extend it. So we do UP connect to the signer, and we call supports interface with OX, AA, BB, CC, DD. And let's see the result. Obviously now we didn't add the extension yet, so it's okay if it returns false. Let's see. So actually it returned false because this interface ID is not supported by the universal profile, and what we're gonna do now is adding this, we're gonna add this extension. So here we can modify this code to just, instead of adding the extension of buy me a coffee, we're gonna do supports interface bytes 4. Here instead of the coffee maker, we're gonna take the supports interface factory, supports interface extension, and we can log it, supports interface, and then we just replace it here. And so what we're doing, we're first deploying the extension that extend the supports interface function. This extension will support, obviously it's here, this interface ID. And then we're computing the selector of supports interface, and we're constructing it with the LSP17 extension prefix, and then we're setting it on the universal profile. So let's run the script of adding the extension. So it's gonna take a little bit of time. So we can see this is the address, not the coffee extension. I left it. So we can do supports. Actually, it's okay. No one is seeing now. So we can take this and wait till it gets mined. So this is a typo. It's not the address of the coffee extension, it's the address of the supports interface. We're gonna take it and we're gonna, actually we don't need it because we're gonna directly call, we're gonna directly check the interface ID on the universal profile. So before we check the interface ID, this one, and it returned false. But now, if we do it again, calling supports interface, it will be true. So that means not just you can extend the functionality of a universal profile with new functions, but you can also make the universal profile support new interface IDs, and this is good for detection of what feature the universal profile will eventually have. So this was the demo. As I said, if you want to look at the code, this will be all published to this GitHub repository. Thank you.